Hi, everyone. I'm Jim Cahill with another Emerson Automation Experts podcast. Electrification is one of the critical pillars in moving toward a more sustainable future. For example, moving from internal combustion engines powering vehicles to electric motor and lithium battery based vehicles. The demand for lithium continues to snowball, and the battery production process and limited lifespan of lithium batteries potentially means a lot of waste. That's where lithium recycling comes into play. Today, I'm joined by LiCycle Chief Technology Officer Chris Biederman and Emerson's Process Systems and Software President Nathan Pettis to discuss the challenges in recycling lithium and other component metals in these batteries and the role of automation and industrial software in driving safe, reliable, and efficient operations. Welcome, Chris and Nathan.
Hi, Jim. Great to be here.
I do.
Well, it's great to have you both. Well, let's get started. Chris, can you give us a little bit of your background and the genesis of LiCycle?
Yeah, sure. First, thanks for having me today. And I'll start with the genesis of LiCycle. So, as a company, we were started back in 2016. Our co-founders, Ajay Kochar and Tim Johnston, were involved in the lithium industry. They both worked at a company called Hatch. They were involved in the project Space in lithium. And they noticed that there was at least at that point in time, a fairly significant forecast of electric vehicles. And they looked at that and said, well, there's a lot of raw materials that go into making the cells for batteries, but there was no viable solution at the time for what happens when those lithium-ion batteries reach their end of life. So they give them credit, took a risk, and said, we want to come around this idea of electrification and we want to play in that space and be part of it. And so they formed LiCycle. They developed what we now know as our core spoke and hub business model. And we're now seeing in 2022 a drastic increase in electrification, cell production, all these different project announcements. So LiCycle is actively involved in this space. And how I fit in, I'm a chemical engineer. I'm our chief technology officer. So I'm responsible for all of our capital projects globally, as well as research and development at LiCycle and our intellectual property portfolio. So I get to play in anything technology.
Well, that's a great background, and I know I'm going to hit you up with some questions about the hub and spoke and that kind of thing as we get into it a little bit. So thanks for that. Nathan, can you give a little bit of your background and your path with Emerson?
Sure. And like Chris said, I'm really happy to be here, Jim. Thanks for letting me have the opportunity to share some of our work we're doing with companies like LiCycle. Yeah, my background with Emerson, I've been with Emerson about 20 years, 23 years exactly, actually. Almost always in the systems automation part of the business. So helping control and automate facilities like Chris's. And I actually started in the company as a software developer. So like him, I'm a techie at heart, mechanical engineer. Didn't really ever do any mechanical engineering though. Got into controls and software pretty early in my career, and then at some point got my MBA and kind of got into this dark side of sales and marketing, and done a lot of things with inside Emerson, run a lot of different parts of the business, but as I said, always within the automation of the systems and software business. So really happy to be here today, and can't wait to talk a little bit about recycling lithium.
Well, thanks for that, Nathan. Well, it's a real dangerous bunch. We got a chemical engineer, a mechanical engineer, and I'm an electrical engineer by background, also on the dark side of marketing. So, yeah, this should be fun. Chris, I was watching some of the news updates on CNBC, and it was interesting how the life cycle management of batteries was a nice to have around 10 years ago. Now it's a need to have. Can you tell us more about the entire life cycle and participating stakeholders?
I can, yeah. So it's an interesting industry, and the life cycle starts with the raw materials that make up lithium-ion batteries. So we have to go all the way back actually to where those come from, predominantly mines. things like nickel, cobalt, lithium, manganese, copper, aluminum, all that goes into making lithium-ion batteries. So really that's where it starts. And what those raw materials are eventually converted into are something called CAM, or cathode active materials. There's a lot of steps that go in between, but effectively that's what we're driving towards, is the active materials in a battery. Those cathode active materials are then combined with other things like graphite and aluminum and copper foils and plastics to form cells. And I'm not a battery expert on the chemistries of batteries. I like to take them apart and recycle them. So forgive me if I've misstepped a little bit there. But ultimately, what those cells go into are things like energy storage devices and phones and electric vehicles. And so where LiCycle gets involved is actually on the back end. When those cells reach the end of their life, we'll take them and we'll process them through our technology and ultimately arrive back at those raw materials, perhaps not in the same form as when they started, but things like nickel sulfate and cobalt sulfate and lithium carbonate are really what we're after, and we'll eventually sell from our hub facility in Rochester, New York, and others. And so that's where we fit in. That really is intended to close the loop. So right now, there's not a lot of recycled material in lithium-ion batteries. That industry, like LiCycle, is growing. And so over time, you'll see more recycled content of those raw materials in batteries. That's really our goal. The other point I'd like to make on the end of that is we don't just take lithium-ion batteries. We also take in what they call manufacturing materials, or things that are produced throughout the manufacturing of cells that perhaps don't meet quality requirements. Some of the offcuts, for example. We'll take those into our process. We recycle them because they also have value of metals like the nickel and the cobalt and the lithium. So that gives you an idea of generally the life cycle. It is quite a complex one. It's a global industry. It's quite exciting, and we play a part both in the, I would say, in the intermediate with those manufacturing materials, but also on the back end with end-of-life batteries themselves.
Wow, that's quite a bit of different things that you're recovering from there. How are, your process is unique to what a lot of other people are doing. What are its recovery rates? And I think you mentioned most of the materials that can be reclaimed, but are there any others in there as part of that process?
Yeah, so we aim to recover as much as we can. Of course, that's the goal and the objective. So we have a technology model called Spoke and Hub. I've mentioned it a few times, and maybe I'll talk a bit more about it. And I think there's some more questions probably in the conversation coming. But what our technology train really is our Spoke facilities are module based or modular, smaller facilities where we do pre-processing of battery and battery materials. And then our hub is hydrometallurgical recovery, which means water-based chemistry for the recovery of metals effectively. And so when I look at recovery process, it's really across the board on our technology train or our full technology suite. And we're driving towards 95% recovery of all the materials in a battery, although things like the electrolyte solvent, for example, is not something that we actively recover. Just based on our process, it goes into our Spoke facility, into the solution, and we'll get into exactly what we do in our Spoke, I'm sure, in a little bit. But most of what we recover is the metal value, so the aluminum, the copper, nickel, manganese, cobalt, lithium. That's really what we want, and we're driving towards that 95% recovery rate for those materials.
Wow, that's really getting a lot of that value back out of it. Nathan, let me turn to you. With lithium-ion battery recycling so important in the global drive for greater sustainability, it's great that we're working with LiCycle on their process automation. Can you share Emerson's sustainability framework, and I guess specifically that greening by part, to help our customers achieve more sustainable operations?
Sure. Yeah, I'd say, our framework is built around really three pillars. One is greening of. So we work really hard inside Emerson to try to make ourselves more efficient every day, using different types of programs around the globe to green ourselves, the scope 1, 2, and 3, the things we use directly with, assets we own that use energy, and then our supply chain, et cetera. So that's greening by. And on the other end of the spectrum, we have Greening With, where we partner with universities or government bodies around the globe to steward new programs or research to try to make the world more sustainable or come up with new ideas and new programs to drive more energy efficiency or all kinds of things. But the pillar that, you mentioned greening by, that's really where we can change probably the biggest chunk of energy reduction and optimizing and sustainability programs when we work with customers like LiCycle. There's there's just a tremendous amount of work our software and devices and solutions do every single day, regardless of an industry, regardless of the customer, to try to make those customers help those customers run their operation more efficiently. And those are really important programs. I mean, every single time we help run a boiler a little more efficiently than it would otherwise, it's saving energy. Those things are being done every day around the globe with thousands and thousands and thousands of facilities. But then once in a while, we get to work with a company like LiCycle, which is truly revolutionizing a part of our society to try to make the world a better place by tackling a problem, like in this case, recycling lithium, that we all know is going to be something for the next number of decades we're going to have to deal with as we have more and more electric cars and other ways to power electrification of other devices around the globe. And that's really, really both fortunate and powerful for us to be able to work with those companies because they really are trying to change the world. And so it's our software, our our devices, our intelligent products that help them run their facilities, but also as they go and build out their plants around the globe, the spoken hub that he'll talk about, we want to be there the whole time. So greening by with you working with our customers to green their operations is really the place that we can make the biggest impact.
Yeah, and that's so true. Anytime you get out on the roads, you see more and more electric vehicles. So that trend is just rolling and rolling there. So it's great that we can work with companies like LiCycle who are tackling that challenge, not just around the spent batteries, but in the production process, the waste and everything else. That's great. So, Chris, what are some of the significant technical challenges in this brand new one of a kind type process that y'all have?
It's a good question because that's what keeps me and my team really excited about the industry that we're in and what we're doing at LiCycle. I mean, there's a lot of different technical challenges, of course. When I look outside of the walls of the company, we have to keep abreast of the changing chemistries, for example, in cells, all the different new technologies that cell makers are coming out with in terms of the mix of different types of metals, some of the different anodes that are coming out, and just battery technologies in general, because eventually those technologies will come to us, and we have to be flexible in how we accept and recycle those materials. Internally, when I look at what we're doing, we've made some really interesting strides this year, I'd say. Um, we have a number of spoke facilities in North America. We have one in Kingston, Ontario, and one in Rochester, New York. And we just have rolled out two additional ones, one in Arizona and one in Alabama. And the spoke facilities for us in Arizona and Alabama are unique because they can process full packs. So that is essentially a pack from an electric vehicle we can take and process all the way through to our intermediate products at our spoke facility. And as far as I'm aware, it's the first of the kind in the industry to be able to take a full pack and process that without dismantling, without discharging as well. And we can get into some of the reasons why that's a unique technology for us in general a little later on. But we've got some really cool innovations going on. We're starting to see those roll out into our asset mix of what we're building at LiCycle. And that's only on the spoke side. When I look at things like our hub technology, of course, there's a lot of innovation that goes into that. We use off the shelf equipment and controls equipment as well. But what we do is we put it together in the right way and we run it under the right conditions to make it unique for the feed material that we get. And so we have a very rich feedstock, I would say, of high quality metals at high concentrations, and therefore our process is designed to recover the nickel, the lithium, and the cobalt from that. So quite interesting. Lots of innovation going on inside and outside the company, and we're really active in that, which is an exciting place to be as a chemical engineer.
Yeah, it sounds like there's a lot of technical challenge in there taking it through, and some solve like, working with the complete pack instead of having to break it down into components and work with it. Um, I guess beside the technical challenges, I imagine there's logistical challenges in this. Can you talk through some of these challenges and how you address them?
Sure. So we've structured our business so that we can address some of the logistical challenges. So as you know, let's say with electric vehicles, at their end of life, batteries could come to us through a variety of different ways, and that could be from the OEMs directly. It could be from a dealership network, but ultimately, it's really distributed as electric vehicles throughout, in this case, the United States. So the question that we have to answer is how do we best get the batteries safely to one of our locations, process them fairly quickly to what we call intermediate or more inert products, and then ship those to our hub facilities or other assets that we have. And so again, going back, and I keep talking about the hub and the spoke model, but maybe we'll dig in a little more. And so our spokes we deploy to anywhere that has a demand for recycling or pre-processing of lithium-ion batteries. So in that case, we can put them in areas of high demand, perhaps co-located with cell manufacturers or OEMs. And really, what that's intended to do is take the battery pack, which is probably the highest risk for transportation, and move it to a pre-processing location quickly, and then process it through. And we do that through our spokes, and we do it in what's called submerged shredding. So effectively, we take a battery pack and we process it, we shred it or deconstruct it underwater effectively. And that has a number of benefits, predominantly safety and health. And it allows us to take a pack and convert it into three products. One, a shredded plastics product, which is fairly low value, but it's something that we recover and we take very seriously to try and get that back into the economy. I would say a mid-value product, which is shredded copper and aluminum foil. So think of aluminum foil in your kitchen, only much, much thinner. And we get small pieces of that, and that is the current collector in a battery, the positive and negative current collector. We catch that and we produce that as a product. And then lastly, we get what's called black mass, and that's an industry term. It's really the graphite and the oxide, the metal oxide materials in a battery, and it's combined for us, and we filter that out of our solution, and that becomes really the key intermediate product for us that we ship to our hub, and that's where we start to recover the metals in that black mass material. Um, it's an inert product, so everything we produce in our spoke is inert, and that allows us to safely ship it to the different assets that we have for post processing. So that's how we handle logistics at a high level. Of course, really, it's driven by shipping and safety for us. That's the two critical.
Yeah, that's really interesting. And I have a follow-up question down the road a little bit on that. To take a battery, which is a highly charged thing, to be able to drive a motor to get you down the road or whatever else it's doing into an inert product that's safe to transport for further processing. That's really interesting. Nathan, I guess given the technical and logistical challenges that Chris highlighted, what are some of the industrial software and automation solutions that will play an essential role in this project and future projects to come?
Yeah, well, I think, as you mentioned, the spokes, they collect all the material of the spokes, they break it down, and they'll ship the main material, the black mass material, to the hubs. And our control automation system is what they've selected for their first refinery in Rochester, their hub there in New York. And it's really become sort of the central nervous system of their operations, at least for that facility. And we feel innovation is really important, and most of the innovation that we bring to market, we try to do it before customers like LiCycle know they need it, or any of our customers know they need it, and it's usually done through software. So as they're building their facilities, Chris and his team will be looking at ways to innovate how they operate the facility. Whether it be simulation, digital twins, training their operators, and time maybe even more and more autonomous operations. And Delta V has got that software built in. And so as they decide to leverage more and more of that control and automation capability at that one facility, that will be something useful for them. And then as they want to integrate their spokes in the operations across the US or other hubs, they'll be able to do that. And then ultimately, we hope to partner with them as a programmatic partner so that layer across that one refinery can be used and duplicated at other refineries that they may build across either the United States or even globally.
Yeah, that sounds like that role of technology in there, not just the making it operate safely and reliably and everything, but the data that you get from it to optimize what you're doing. And as more of these hubs and spokes get out there coordinating among them. Chris, I've heard you mention urban mining or mining above ground. Can you tell us how that's helping out the supply chain and the commodity shortages in some of these areas around batteries around the world? And how is that affecting your business?
Sure, we do like the term urban mining because what we're getting is really a refined product or a refined product at its end of its life in a term or in the form of a lithium-ion battery. So um, we look at that as you have a cell phone, for example, or in your garage, I'm sure you have a battery-powered drill that you use around the house. We take all of those materials and we'll convert them back into their raw materials to get that back into the industry. And we have a way of doing that fairly quickly. We can be agile. Of course, with our spoke rollout, our hubs are a little less agile given the size of the investments. But we also think that because these are refined products, our feedstock material is quite high value, quite high in concentration of metals. And therefore, what that allows us to do is capture the value and push it back into the supply chain, hopefully a little bit quicker than it takes to permit and get moving on a primary mine, for example, for lithium or for nickel. Now, I think over time, recycled content of these metals will continue to increase in batteries, but will play a role alongside other commodity producers or other nickel, for example, and lithium producers. We can't do it on our own, and they definitely need to start incorporating recycled material into cells. So we work well together. We have to. That's the goal of making sure that we alleviate the supply chain and commodity issues that you're speaking about. We have to play a part in recycling. I think it's the right thing to do when you look at the amount of global resourcing that's put into making a battery in terms of the raw material supply and all the different smarts of people and different companies that come together to produce a cell and ultimately an electric vehicle that you can drive on the road. We kind of owe it to ourselves to use the materials wisely as they are finite and they do take a lot of effort to in most cases dig out of the ground first in order to get them into batteries. So I like to look at it as the right thing to do from an environmental perspective, and it just so happens that there's a very solid business case behind that as well for us.
Yeah, and it seems like as that growth continues to happen over time, that recycle seems like it would play a larger and larger role in that whole process. So that really is, will be a significant and even more significant piece as we move forward. Nathan, I understand that the initial projects are on a fast track. What are some of the project methodologies, technologies, and I guess team makeup used to help execute the project to meet the timeline?
Yeah, Jim, a company like LiCycle, they're investing heavily to try to bring this technology to market as quickly as they possibly can, and they need to have a partner that will help them execute these projects in a timely fashion. They are aggressive schedules, and good, solid project management, project execution has got to be done with intent. And we look at it we take it very seriously. We've built our capabilities over the years. We weren't very good at it, 20, 25 years ago, but we've become very good at it. And to me, it really takes kind of a Venn diagram of people. You've got to have really good people that have domain expertise. In this case, a blend between mining and chemical processes. You've got to have procedures and documentation tools, things that you can do over and over. You can't just rely on just the best people. You've got to have a team of people that follow the same processes globally or regionally, and then technology. So it's kind of a blend between people, technology, and process that really have an execute a project really well, particularly a fast track project like these. And we have 6,000 people around the globe we can bring to bear to programs like this. And we really do take it very, very seriously and have done a lot of it around the globe. And we're very excited to work with Chris and his team on this project. But there are some things that we feel like we do really well that are technology based. Smart commissioning is a great example. So as you're building a plant like they are, you will invariably find out that you wish you could have measured something you didn't think to measure when you put the design together. If only we had this temperature, if only we had this pressure. And while it may sound like a simple thing, well, you just order another device and you put it in and you measure it. The configuration of that device that wasn't pre-configured, wasn't set up, can put a big gap in the schedule. And we have the capability to have that device shipped from the factory readily, pre-configured, so to speak, show up, wired up, and it automatically uploads into the automation system without any intervention from people. So those types of technologies, another one that we use a lot, we call it electronic marshaling, but basically it's a technology that allows, if a module were to show up at site, and maybe that had been specified with three types of measurements, and instead of those three types of measurements, they came in with different types of measurements. And so typically you would have to change the IO cards, you would have to change the configuration. Our technology allows you to basically just change those three signals very quickly, and through software essentially change those IO types on the fly, again, without having to do any paperwork or documentation or any of that, because it's all done automatically. So while those things understand, each one of those individually may not take maybe a day or two. If you're in the middle of trying to start the plan up, those 2 days could be a huge deal. And more importantly, sometimes they can have waterfall effects that could change by weeks. So they're really, really important. And so we do think between that blend of technology, having the right processes, and a lot of really good domain expertise in our people, we can help companies like LiCycle even in the fastest, most critical timelines.
Yeah, I know you get towards the end of the project, those changes come in, and it's nice to have technology be able to adapt to it without setting the project back delayed a week or weeks or whatever else in there. So that's a real good advancement, because I don't know any project, the way you draw it up is the way it is installed and ready to go. All right, Chris, I know we spoke a lot on the spoke side of it and that initial breakdown of the battery into the components that could go over to the hub. And it makes sense in that model. Those are highly decentralized, spread out, doing their thing. Can you talk a little bit more about the hub side and what goes on with, what they receive in from the spokes to get to where the finished recycled product that you're looking for?
I can just forewarning, this is the exciting part for me, so you might have to rein me back in if I get too deep. But the hub process, I think, is really neat. It's again hydrometallurgical, so water-based recovery of metals in our case. There's of course reagents that go into it, and we'll speak a bit about that. But the key points for us is that it's water-based chemistry. It's low temperature. I think the highest temperature we run is somewhere around 180 to 190 degrees Fahrenheit, so less than boiling, quite low temperature. It's a patented process. I forgot to mention that with our spokes as well. So we have a patent around our spoke and our hub as a core technology for LiCycle. So we've done a lot of work on this one. Spent about a year in piloting, if not a bit more, before we rolled into the full commercial design. That's the lead up to what we've done on the hub. The hub itself is roughly 10 different areas, all combined into a hydrometallurgical plant. So they all play together and they all have a function. But effectively, it starts with us taking the black mass material from our spokes, and we slurry it up. We make it a slurry, and then we leach all the metals with acid. The intent there is to really dissolve all the metals, and once you have them dissolved, the game is really to systematically pull them back out again out of solution into the product form that you want. That's the high level. It's not nearly as easy as that, but we have a number of unit operations that we work through. So the first couple are looking at recovering things like copper and aluminum and iron. The middle section of our plant is what's called solvent extraction, and that's where we do a lot of the heavy lifting to recover manganese and cobalt and nickel. And then the back end of our facility is really focused on lithium carbonate recovery. So a lot of those unit operations are independent, but then all linked together. And that's where controls become really important, because you have all these different systems that are working and really producing different types of materials or products for us. And they all have different operating conditions, be it pH or temperature, or addition of reagents like acids or bases. So really a neat process. As I said, we spent a lot of time developing it ourselves, getting the operating conditions right, and then turning that into a full-scale commercial design, which is what we're working on now. Our first hub is going to be in the Greater Rochester area in New York State. It's an old piece of land that was owned by the Eastman Kodak Company. So a lot of really good infrastructure there that's supporting the plant, or that will support the plant. For LiCycle, it's a $485 million investment, so quite significant for us in our first step into the hydrometallurgical recovery of metals.
That sounds like a fascinating process as it's going through, and you're stripping off the different metals out of it and bringing them together. That's really cool. Nathan, I guess given LiCycle's plan for additional hubs and spokes across the globe, can you describe the role of what we do as far as standards and treating the project as a program instead of a single project?
Sure. When we get to work with a customer like LiCycle that wants to, selects us as their partner for a project like this, but also has expansion plans. It's really great for us. It's great for them. You can think of a program as almost a series of projects. So Chris talked about their first hub that they're gonna put in place there in New York. We'll learn a ton together through that project. No matter how well we plan it, no matter how well we work together up front and we work through these projects, we will find things that we learn together. But all of those things can be captured and will be captured. So Emerson, a program is a series of projects where it takes long-term dedication and frankly, partnership. We love them because it allows us to kind of co-invest, or not kind of co-invest with our customers, right? We'll put a dedicated team in place that will over time continue to work with LiCycle as they build hubs and spokes and hubs, regardless of where they are, whether they're in the United States or beyond. That team can stay intact. We have technologies that allow that remote team to be almost as if they're in the same location. And then we'll start to build out libraries and templates and things that they can reuse from plant to plant to plant, and frankly, our own domain knowledge around LiCycle's process. Because while we may have a tremendous amount of chemical processing, refining capability, or mining expertise, and understand the raw sort of low level or high level, I guess I should say, chemistry or mining dynamics, their process, as he just said, is patented. That means no one's done it before. And so there will be things we'll learn through this first development of this first hub that we'll codify, protect for them. It will be theirs and ours together to be able to reuse. And we really do appreciate not just this opportunity, but the long-term opportunity with them around the globe. And then finally, after each project gets finished, you've got to support it. One of the things that's very important to customers like LiCycle, they told us as they were talking to us about this program, is they want to make sure that they have the support they need at those facilities to keep the plants running. And we have a dedicated group of offices around the globe, or impact partners in North America, or sales offices around the globe to help them keep those plants running, which is very, very important, because if you're going to spend $500 million on a facility, you need it to run all the time for many, many years. And so all three of those things are important. Keeping those projects going and making sure we learn what we do through the projects, and then supporting them afterwards.
Yeah, it's you take the learnings from the first and then apply what you can and just keep rolling through as you're growing this over time. Chris, there's one I probably should have asked it earlier, but lithium-ion batteries are in everything from our cell phones, PCs, watches, automobiles, everything else. Does this process work with all the different types of lithium-ion batteries that are out there?
It does. So I consider our spoke facilities what we call chemistry and form factor agnostic. So effectively what that means is you could put pretty much whatever you want in there that's a lithium-ion battery within reason, and the spoke won't really matter. It'll produce its three key products out of that: the black mass, the foils, and the plastics. So very, very flexible on the front end. When we look at the hub, it's a little bit different. So the hub of as a hydrometallurgical facility has to be designed to work within a limit of chemistry, let's say. So our first hub in New York State is predominantly designed for nickel, cobalt, manganese chemistries. The alternative that you're seeing in the industry now is LFP, if you've heard of that, lithium iron phosphate chemistries. Those are starting to, I would say, become more prevalent. And so we have a process ourselves that we've developed to actually recover lithium from lithium iron phosphate derived black mass. So we can take some of that into our hub in New York State, but we also have a dedicated process that as that chemistry becomes more prevalent, we'll start to look to roll that out as well to, again, be agile and look at what's coming from a chemistry point of view outside of our company, of course, and then how do we manage internally. So very long-winded way of saying we have flexibility in both the front and the back end of our technologies, but certainly the spokes are very agnostic when it comes to what types of batteries you can feed them.
Yeah, and it sounds like you have to be on your toes for what's getting developed coming out that may, put the others away. So that keeps it exciting, never a dull moment, I imagine. Well, let's start winding things down. Nathan, do you have any closing thoughts on our work with the LiCycle team?
I guess I just say it's really both a pleasure and something super exciting for us to be able to work with a company like LiCycle. I when I talk to my own kids about things like they're doing, they can explain. I can explain it to them, and they can get it. They understand how recycling the batteries that they see being used in their computers, or certainly the cars that they may drive someday, is really important. And it means a lot to us and our employees to be able to work with a company like LiCycle. So we want to make sure they're successful. They need to be successful. The world needs companies like LiCycle to be successful. And it's really something special to be able to work with them. I tell our employees, I tell myself every day, you may not know our products change the world, but our products and solutions help our customers change the world. And that means an awful lot to us. So we're very grateful and honored and humbled to help them, and certainly we'll do everything we can to do that.
Yeah, I think you're a company that we can brag to, people we meet that ask, what does Emerson do, in ways that we help our customers and the things they do that are changing the world. So, Chris, how do you envision everything unfolding over the next several years?
Wow, LiCycle is extremely active, I would say, and we're pretty excited about the industry that we're in. So, if I look at our portfolio, we're very quickly moving into Europe. So that's our focus right now. We've announced, of course, a spoke in Germany as well as in Norway, and we're actively moving on those two. You'll see, I think, more from us as we continue to grow our spoke network as well around the world. Our first hub, of course, we talked about in Rochester, New York. That is a key component for us as we go forward over the next year to 2 years. So be focused on that, and that's a big milestone for our company. So I guess all I can say is really excited to see where LiCycle goes and to be a part of it, to bring new technologies into the industry is just it's great, and to have a great partner in Emerson is also adding to that. So I appreciate your kind words, Nathan.
Well, we're really excited to be part of that journey too. Well, I want to thank you both so much for sharing your insights with our listeners, and we look forward to seeing how this future unfolds. And I guess for our listeners who wish to learn more, visit li-cycle.com for everything they're doing. Chris and Nathan, thank you so much for joining the podcast today.
My pleasure. Thank you.